Hello everybody, now we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. This is question number 6.19. 6.19 and the question is find the equivalent capacitance between terminals A and B in the circuit. All capacitances are in microfarad. Okay, so this is the circuit given. So when you have a look at this 30, this 20 and this 10 are connected in parallel. Okay, so for the parallel combination, the equivalent value is just adding them together. So it is 30 plus 20 plus 10, that is equal to 60 microfarad. Okay, so after that, if you have the circuit gets modified as this is 12 microfarad. Then here you have this combination, parallel combination actually as 80, and then here you have it as 40, right? And on this side only you have this 16 microfarad now, right? After replacing these three capacitances, you'll be getting it as 60 microfarad. Then here, from here to here, it is 12, and then between these two, it is 60 again. It is 60 microfarad again, and between these two you are having this is 50. Okay, so we know that these two are in parallel, right? These two are in parallel, so its combination is nothing but 80 plus this is AB. Okay, fine. So if you have to look at this 40 and 80 microfarad capacitances are in parallel. So when you have the parallel combination, it's just adding them together, right? So it becomes 80 plus 40 as 120 microfarad for this combination. Now we can again redraw the circuit. So this can be redrawn. This is 12, and here again another is capacitance. It is 120. Then here you have this 12. Okay, this is B. So okay, fine. This is 60. This is 60. In between we have this 50. So for this, these two 60 microfarad capacitors are connected in series, right? So when they are connected in series of equal value, you get the half of the value as equivalent value. Okay. Or otherwise, if you go by formula, it is 60 into 60 divided by 60 plus 60. What it is 60 into 60 divided by 120, right? 2 times. So this is 30, right? So you'll anyhow get the answer, same answer. Okay. So now we are going to modify the circuit again. So we'll be getting it as this A, then 12, then here you have this 120, here again 12, here it is 50, right? But here you have this combination becomes 30. So this is AB. So now you have the look. Now you can see that these two are in parallel, right? So when they are in parallel, just add them together, so it becomes 80 microfarad. Okay, so we can redraw the circuit like this one 12, and then 120, then here again 12, then you can put this as here as 80. That's it. See here, these two are connected in now series. So for series combination, how do you calculate? It is like 120 into 80 divided by 120 plus 80, right? So what's the value for this? It is 120 into 80 divided by 200. So you can cancel out these two. This becomes 4. So what it is? 48. So now we'll get the modified form of this. So what it is? Here it is 12. So we'll get the modified form of this as this is 12. Then you have the equivalent value as 48 microfarad here. And here you get this 12. Okay, this is AB. Now you can check it as this 12 and 48, they are connected in parallel, right? So you can calculate it as just the sum 12 plus 48. So that is equal to 60 microfarad. So once again redrawing the circuit. This is 12, then this combination is 60. So this is A and B. So you can very well know that these two are connected in series. For series combination, it is 12 into 60 divided by 12 plus 60, right? So it is 12 into 60 divided by 72. So it is 10. So the equivalent value is 10 microfarad. So you can simply write this as, so the equivalent capacitance is 10 microfarad. C equivalent of this circuit is 10 microfarad. So this is your answer. So what is the C equivalent? C equivalent is 10 microfarad. So this is your answer. Okay, thank you.